Hey students, welcome back to my channel, and today I'm going to discuss about class 9's the first chapter, that is number system. So number system actually you all have done up to class 8. But here we will be doing little bit extra, but not in this session, but later on in the next all sessions we will be discovering all the elements related to number system. So to know about number system, we first know about the numbers, and the first type of number or the category of number you can say that we always deal with, that is natural number. So number one is natural number. Natural numbers means what? These means all counting numbers. Now counting can't be started from 0. Counting can't be started with -1, -2 or like that. So counting, when I'm calling it as counting numbers, it must be always starting from 1 and then gradually going to be increased like 1, 2, 3, 4. Just to give you very simple example, suppose if somebody asks you that how many students are there in your class, it is quite obvious that you will be giving them a figure, a number. But how you got that number? You must be counted. Already you have counted. How you have counted? 1, 2, 3, 4, like this. So these all counting numbers are natural numbers. Why natural numbers? Because it comes naturally, and we started our journey with numbers when we were kid. Actually they were natural numbers. Okay, so natural numbers are 1, 2, 3, 4, dot dot dot, going up to infinity. Natural numbers, the whole collection is denoted with capital N. The whole collection of natural numbers is denoted with capital N. Number 2. Number 2 is whole numbers. Whole numbers, it is denoted with W, capital W, and actually natural numbers are obviously there. For whole numbers only 0 will be added. So whole numbers start from 0, then going like this 1, 2, 3, 4 and up to infinity. Number 3, integers. Integers collection is denoted with capital Z. Integers means it will be actually starting from -infinity, comma, dot 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 dot. Suppose -2, -1, 0, 1, 2, dot 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 up to infinity. What does it mean? It means you can see in integers collection, natural numbers are there, whole numbers are there, and what are there extra? There are negatives of all natural numbers. All natural numbers are 1, 2, dot 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 up to infinity, and their negatives are -1, -2, -3, like that up to minus infinity. So in integers collection, 0 is there, natural numbers are there, and negative of natural numbers are also there. Now from here to here, that means from minus infinity to -1, where we have a negative sign, we will call it as negative integers. And from 1 to infinity, mind it, I haven't included 0. So from 1 to infinity, these are positive integers. Related to that, I just want to say one thing. You can now see that positive integers are actually natural numbers, right? So positive integers, natural numbers. That means these natural numbers we can write down positive integers, right? Okay. Now, so we have got natural number, whole number, integers, positive integers, negative integers, and then coming to 0. 0 is integer, but it's non-negative, non-positive. It is not positive, it is not negative. That's why 0 is called as non-positive, non-negative integer. So this is non-positive as well as non-negative integer. I hope up to this you all have got the idea. Okay, then I'm just rubbing this part. Next one, our next category is rational numbers. Number 4 category is rational numbers. Rational numbers collection is denoted with capital Q. What is rational numbers? I know you all have done up to, already you have done this particular topic, rational numbers, in class 7 and 8 in both the classes. But still I just want to recall the definition of rational number. Now rational numbers definition, the number which can be expressed in P by Q form, or if somebody is comfortable with A by B, no problem with that. So P by Q form, first thing must be that is P and Q are integers. This is number 1 condition. Number 2, Q not equals to 0. Q will not be 0. Number 3, it is not written over there, but ultimately you will be getting it. So I'm writing ACF of P and Q equals to 1. Now what does it mean? This statement, what I have written, ACF of P and Q equals to 1, it means P and Q don't have any common factor other than 1. Okay? And this leads to a new term, that is co-prime. Co-prime. Now look, prime number is different. Co-prime is different. What is co-prime numbers? Co-prime numbers definition is this. You can take any two numbers that may be composite, may be prime, but if you are taking two numbers together in a pair and you are seeing that those two numbers don't have any common factor other than 1, then they will be co-prime. Regarding that, I just want to give you some examples so that this concept will be properly clear in your brain. So co-prime, what I was telling, look, you can take 2 and 3, but they are prime numbers, right? I'm starting with prime numbers. 2 and 3, they are prime numbers. So 2 and 3 don't have any common factor other than 1. 1 is always a common factor, so that's why we have written other than 1. So except 1, they don't have any common factor. That means these two are co-prime, right? Now I'm taking, suppose, 16 and 25. You can see these both numbers, 16 and 25, both are composite numbers. They are not prime numbers, but still they are co-prime. How? Because of this definition. Look at 16 and 25. 16 has the factors as only 2. 2 into 2 into 2 into 2. 25 has the factors as 5. 5 into 5. So you can understand now that 16 and 25, they don't have any common factor other than 1. That means 16 and 25 are co-prime. What you can say after it? Co-prime means, suppose you have got a form like 16 by 25. Okay? So this 16 by 25 is in simplest form, right? Because you can't cancel it with any factor. So this is in simplest form. So you can say that a rational number, that means a number which is in the form of p by q, where p, q are integers, q not equals to 0, and p by q is in standard form or in simplest form, that also can be written. Then that fraction is called a rational number. Okay, that is called a rational number. I hope you have understood this idea about rational number. Rational number is very much well-known topic, very much well discussed topic, but still somehow this co-prime, standard forms, simplest form, in this portion students get confused. So I hope I have given you the clear idea. Okay, so let's go to the next part. So rational numbers are this. I'm rubbing this one also. Okay, so these are all categories of numbers that we are dealing with. Now there is a point that we have to plot a rational number on number line. Number line everybody knows. I'm drawing a number line. Please look at this process minutely. I'm properly elaborating it. So I'm not skipping any part. Think about, this is 0, this is 1, this is 2. You have to plot. Suppose you have to plot 2 by 5. Look at this first. 2 by 5 is proper fraction or improper fraction? This is proper fraction, right? Now what is proper fraction? Everybody should know it. Proper fraction means the numerator always will be less than the denominator. That means numerator will be smaller, denominator will be larger or greater. That is proper fraction. Proper fraction means its value always will be less than 1. Proper fraction, whatever proper fraction you take, it will always be less than 1. Obviously positive. Okay, I haven't given any negative sign here. So less than 1, that means it must be plotted anywhere between 0 and 1. Okay. Now we will look at this 5. So we need to make 5 gaps. Okay. How? 1, 2, 3, 4 and this one 5. That means if you have 5 as the denominator, you need to put in equal division 4 lines. Again I am repeating, if you have 5, you need to put 4 lines. If you have 7, you need to put 6 lines. If you have 13, you need to put 12 lines. Okay? So we have got 1, 2, 3, 4, 5 spaces. Okay? These portions are 5 portions. It is divided into 5 equal parts. Among 5 equal parts, we have to take 2 parts. How we will calculate? 1, 2. Again I am telling 1, 2. So we have got 2, we are circling this. Once we have encircled this, this will be our required number, that is 2 by 5. Clear? Coming to the second category, that is, suppose you have got improper fraction. Suppose I have got 5 by 3. So you can see that numerator is larger, denominator is smaller. That means this is improper fraction. Okay? This is improper fraction. Improper fraction always will be greater than 1. Improper fractions value always will be greater than 1. For improper fractions, we will not directly put it on the number line. We will not directly put it on the number line. What we will do? We will make it in mixed fraction first. So what will be mixed fraction? This will be 1 whole 2 by 3, right? We will deal with 1 whole 2 by 3 and we will plot this one here on the number line. How we will put that? Now look at this. We need to just, what I can say, we need to break both the parts, whole part and the fraction part. So this one is actually 1 and 2 by 3, right? So we will first go to the whole part. We have got 1 here, that means we have started from 0, we have gone up to 1, then we are stopping. Then we will look at this 2 by 3 and look, 2 by 3 is like 2 by 5 proper fraction. But this proper fraction must be plotted between 1 and 2, not 0 and 1. Because already up to 1 we have travelled. So from 1 and 2 we need to plot 2 by 3. Again I'm telling, for 3 we will take 2 lines, that means 1, 2. Okay, what we will count up to 2? 1, 2. So this will be encircled, and this encircled point is 1 whole 2 by 3, which means 5 by 3. I hope that I'm clear here. Okay, now what we will do, we have got this for positive fractions, positive rational numbers you can say. The same way we can plot it in negative parts also. Only what we have to do, we have to start from 0 and go to left hand side. We will not start from this side to this side. Always our O is, this is 0 point, or we can say this is the origin point. Origin means the initial point. So we will always start from 0. Okay, always start from O. Okay, so I'm rubbing it. So students, I have chosen a question for you. Already I have written on the board. So I'm just reading it once. Is 0 a rational number? Can you write it in P by Q, that is rational form, P by Q form, where P and Q are integers and Q not equals to 0? So is 0 a rational number? You might be thinking that whether it is rational or not rational, but the answer is yes. 0 is also a rational number. So first answer is yes. So once we have got the answer as yes, that means our next question comes that can we write it in P by Q form? Yes, also we can write it. So 0 can be written in P by Q form in any ways. Infinite ways. Look at this. 0 I have chosen 1, 2, 4, 9. You can choose any number. Any number. So obviously any integer. 0 by 1. We are already today only in this session we have done that 0 is an integer. So 0 is an integer, 1 is an integer. So we have got this form, both are integers and 1 not equals to 0. Similarly 2 not equals to 0, 4 not equals to 0, 9 not equals to 0. So we can write 0 in infinite times P by Q form. Okay, so 0 obviously a rational number. Okay, now this is your question. This is the question number 1 of exercise 1.1 from NCERT book. Okay, this is from NCERT exercise 1.1 class 9's book, and this is the question number 1. Question number 4. I have my book. So question number 4. State whether the following statements are true or false. Give reasons for your answers. So number 1 question is, every natural number is a whole number. True or false? You think about that. Every natural number is a whole number. True. Because in the first half of today's session, we have done it. When we wrote all the categories of numbers, natural numbers are 1, 2, 3, 4, dot, dot, dot. So this is natural number and this is the collection of whole numbers. So it is quite obvious that 1, 2, 3, 4 are natural numbers as well as whole numbers. So every natural number is a whole number. That is true. So question number 4, number 1 answer is true. Number 2, every integer is a whole number. No. Positive integers obviously whole number. 0 is also whole number. But what about negative? In whole number collection, there are no negative numbers. So we can say that negative integers are not there in whole number collection. So we can say that every integer is not a whole number, or answer will be false. Okay? Coming to number 3. Every rational number is a whole number. Every rational number is a whole number. Can't be. Because rational numbers are in the form p by q. Whole numbers are in the form whole form. So there is no fraction included over there. So rational number is not a whole number. No, not all. But obviously in rational there are these numbers, because you might be thinking that only fractions are rational number. No. 2 also is a rational number, because 2 by 1 can be written. 4 is a rational number. 4 by 1 can be written. But all rational numbers, because I have between 0 and 1 half. Half is a rational number but not a whole number. Okay, so this is also false. So students, this is all about today's sessions. I hope you all have understood everything, and I hope that now you can do by your own many things related to this topic, today's topic. So we will meet in the next video with any other topic. Till then, bye bye and have a good day.